Okay, finding the center of mass of a hemisphere by calculus. So here's the statement. Find the center of mass of a uniform hemisphere of radius big R and mass big M. All right, so we shall sketch this out. We have our base and the top coming up, and it's all of radius big R. So from the middle, we can come out in any direction we want, and we get big R. All right, what are we going to do with this? Well, we're going to take and slice it up from the top, because it's actually really easy if it's uniform to tell what the center of mass is along the other two directions. So along these two directions, along x and y, it is just going to be at the geometric center. Vertically, we can't intuit that out, though, because it's a hemisphere. So we're going to slice it up, and each of those slices is going to look like a little disk with some radius little r and located at a height z from the bottom. Okay, so let's see. In this case, it's a density-based one, so we need to think about density is the mass over the volume, and that's equal to dm over dv. So in this case, the mass over the volume is half of a sphere. So if a sphere is 4/3 pi r cubed, this will be 2/3 pi big R cubed. All right, and then we can rearrange that a little bit. 3m over 2 pi big R cubed is dm over dv. So what is the volume of this slice? Well, dv is going to be pi times little r squared times, this is along z, we're slicing it up into slices along z, so we get dz. All right, so that lets us write dm must be equal to 3m over 2 pi big R cubed times dv, which is going to be 3m over 2 pi big R cubed times pi times little r squared times dz. And we can cancel that pi out. All right, so dm will be 3 big M r squared dz all over 2r cubed, big R cubed specifically. All right, here is the problem. Z and R are related to each other. And in fact, if you imagine taking a vertical slice through this, we can actually draw out that z comes up and r comes out. Z looks awful, let me try again. And big R will actually come through the middle. It actually forms a right triangle, or you can use the idea that they fall onto the equation of a circle. That means we can write r squared plus z squared is equal to big R squared, which this is going to work out really well for us. We want to write r squared in terms of z, and that's just going to be big R squared minus z squared. Okay, looking at z, we start at the bottom, we go to the top. We're going to be integrating from 0 to big R. So let's do this. ZCM will be equal to 1 over m integral of z dm. So we're going to get 1 over m integral of z from 0 to big R of 3m over 2 big R cubed. Then we have our r squared, which is big R squared minus z squared, and dz. Let's see, cancellation. Well, the m goes away. The only other thing that we can pull out is actually the 3 over r cubed. So we're going to have ZCM is 3 over 2 big R cubed. We'll integrate from 0 to r. Let's take that z and distribute it. So we have big R squared times z minus z cubed dz. All right, finishing this up, we'll integrate 3 over 2 big R cubed. Then we get big R squared, z squared over 2 minus z to the 4th over 4, and we evaluate in the limit 0 to big R. All right, so 3 over 2 big R cubed. Then we're going to get, let's see, first term we get, well, r to the 4th over 2 minus r to the 4th over 4 minus 0 minus 0. Okay, 3 over 2 big R cubed. All right, 1/2 minus 1/4 is 1/4, because we can make this 2 over 2 and get 2r to the 4th over 4 minus r to the 4th over 4. So we have r to the 4th over 4. We can do some cancellation, and we get 3/8 r. Okay. All right. If I have time to record sometime other than today, maybe I'll give you a pyramid example or something like that, but that's going to be it for now. You've got 2 examples of how to use calculus to do this. Should help a lot in figuring things out. You do have problems on your homework, or at least, yeah, you do have a couple problems on your homework, so you'll need to figure this out. All right, if you have questions, make sure you contact me, because yes, this is hard, especially the first time trying to figure it out. So keep in touch and let me know.